Today, class, we're going to be talking about similar triangles specifically. Yesterday, or in the previous lesson, you learned about similar figures and the fact that similar means that they are going to be the same shape, therefore they have the same angles, but they're going to be different sizes, and the sizes have the same scale factor. We're going to have to use the same multiplier to go from one triangle to the next. So what we're going to look at here today are ways that we can prove that triangles are similar. Okay, if you recall back, think back into last semester, Unit 2, we learned that there were certain shortcuts that we could use to prove that two triangles are congruent to each other. As a quick, recall of those, we learned that we could use side, side, side. That just means that we had to show that all three pairs of sides were congruent. We could use side, angle, side, angle, side, angle. We could use angle, angle, side, and we could use RHL. So we had 5 different ways to prove triangles congruent. We also had 2 methods that we could not use. One of them was the side, side, angle. This is the one, of course, that spelled backwards is kind of the bad word. The other one that we could not use to prove triangles congruent was angle, angle, or angle, angle, angle. Okay, now that one didn't come up quite as much, but it is going to come up a little bit here today, so I did like to mention that. Just to quickly review what you remember from last semester, pause the video for a moment and take a minute to look at problems 1, 2, and 3 and see if you can determine if the triangles in each picture are congruent, and if so, which of the criteria can you use to prove that? After you've kind of tried it yourself real quick first, then restart the video and we'll let you check and see if you are correct. Okay, you should have found that in diagram 1, we can prove the triangles congruent using side, 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 because we have one pair of congruent sides given, a second pair given, and the third pair of sides is congruent due to the reflexive property. Okay, in number 2, we can prove that the triangles are congruent using RHL. In this case, we have both triangles do have a right angle, so that's your R, your right angle. Both triangles have a pair of legs that are congruent, that's your L. And once again, using the reflexive property, this side in the middle is congruent, and that side is the hypotenuse, so we can prove that they're congruent using RHL. In the third example, we can prove that these are congruent using angle, side, angle. Again, we have a pair of angles that are congruent. We have a second pair of angles that are congruent. And then, of course, the side that is in between them is also congruent. So we're going to be looking at some similar tactics here today, but today we're going to be looking at trying to prove that triangles are similar rather than congruent. If you look at the 2 triangles below, we can obviously see that these are not congruent because they're not the same sizes, okay? Instead of recording the lengths in the table, I've actually already identified the lengths for you, but there's a couple of things that I want you to remember. In similar triangles, remember our definition right down here at the bottom in your notes from the previous lesson as well. Triangles are similar if they have been dilated so that all of the angles remain the same. So first thing I want to do is check that. Did the angles stay the same? Well, this one's 45, this one's 45. This one's 60, this one's 60. And since we know that the angles add up to 180, if we do 180 minus 45, minus 60, we can see that this missing angle is going to be 75. And this missing angle will also have to be 75. So it does appear that all of the angles are the same, okay? The next thing we need to see is, are the sides proportional? Now that means that we have to have used the same scale factor, okay? We have to have that same scale factor. Remember, the scale factor is the number that we're multiplying by. I apologize here, my pen seems to be going out a little bit. Okay, so scale factor. If we look at the 30 millimeter side and compare it to the 10 millimeter side, we can see that it obviously has decreased. Some of you might look at that as dividing by 3, but a scale factor is multiplication. So remember, dividing by 3 is the same as multiplying by 1/3. As long as that same scale factor occurs for all of the pairs of sides, then we know they're proportional. So 21 to 7 If we multiply by 1/3, we get 7. Okay, 27 to 9. Again, if we multiply 27 times 1/3, we get 9. So this is evidence that that these two triangles are in fact similar to each other. And remember that for similar, we use the symbol, the one little tilde, to show that these are similar. Okay, now the thing is, we don't want to necessarily have to know all of that information to prove that triangles are similar. So just like with congruent triangles, we do have a few shortcuts. The first shortcut is simply called the angle-angle similarity postulate. Okay, and it's pretty self-explanatory. In this shortcut, we have to be able to show that there are two pairs of congruent angles. Because remember, if two of the angles are congruent, then the third pair of angles will also have to be congruent based on the fact that all three pairs of angles, or based on the fact that the angles add up to 180. If all three pairs of angles are congruent, then the triangles have to be similar. So the nice thing is with angle-angle, you only have to find two pairs of congruent angles, and the third pair will have to be congruent as well. So looking at a quick example of how to do that, if we look at example 3 here, okay, we can see in the first set of triangles, we can see right away that we have one pair of congruent angles. So I've got 1A. Now, the other two obviously don't match, so we're going to have to find the missing angle. Remember, all we need to do is subtract from 180. So if we do 180 minus 110 and then minus the 45, looks like the missing angle here is 25 degrees. Now, since the 30 does not match either one of these angles, that means there is no second pair of angles, and therefore we cannot prove that these are similar using angle-angle. So we would conclude that these are not similar to each other. Okay? In our second example, okay, again, we can see right away that we have one pair of angles that is congruent. They both have a 90-degree angle, so we have one of our angles. The other two don't match yet, but if I find the missing angle, again, remember, we're subtracting from 180, this missing angle is 55 degrees. Once we see that second pair of angles that are congruent, once we realize we have a second pair of angles, now we can prove that these two triangles are similar using angle-angle. And remember, again, the symbol for similarity is just that little tilde, okay? So angle-angle is our first one. Our second one is side angle side. Now that's going to look pretty similar to the congruent triangle. So it's really important that we separate the two and understand the difference between them. So write in bold here. Just to reemphasize, in congruent triangles, we need to prove, and I'll even draw an example here, we need to be able to show that one pair of sides are congruent, that there's a second pair of sides that are congruent, and that the angle between them is congruent. And if that's the case, then we can prove that the triangles themselves are congruent. Now, that's totally different from side angle side similarity, because remember, in similarity, the sides will not be congruent because they're not the same size. So we're not trying to show that the sides are equal. What we're trying to show is that the sides are in the same ratios. So in side angle side similarity, the triangle would have to have two sides that are proportional. Okay, and proportional, remember, that means equal ratios. So we have to be able to prove that the two ratios are equal, okay? And the angle between those sides will have to be, the angles between those sides will have to be congruent. Okay, so remember, the sides aren't going to be equal. Those are going to be proportional. But the angles have to be equal because that's part of being similar figures. They have to have the same angles. So as we look at our example right here, we can see that this angle A is 47 degrees, and we have angle D is also 47 degrees. So we automatically have the A part. We have a pair of angles that are equal. Now, if we look at the sides on either side of it, okay, so right over here we have this side AC, and then right over here we have side DF. What I'm going to do is write a ratio comparing those sides. A ratio can just be a fraction. We can just write 6/3, okay, or we could write 3/6. Then I'm going to look at the pair of sides on the other side of the angle. So I'm going to look at that one, and I'm going to look at that one, and I'm going to write the same ratio in the same order. So once again here, I'm going to write a ratio 4/2. All I have to do now is prove that these ratios are equal to each other. And the first day, when we first started this unit, we talked about different ways to prove that these are equal. One way to prove that they're equal is just to divide. Okay, 6 divided by 3 is 2. 4 divided by 2 is 2. These two ratios are equal. The fact that the ratios are equal proves that I can use side, angle, side to show that the triangles are similar. So then I can say triangle ABC is similar to triangle DEF. Okay, so side, angle, side, little different than with congruence. We have to look at these ratios, and that's going to be a key part of all of this. Okay, the third one and last one here is side, side, side similarity. Now again, in side, side, side congruence, we need to show that the 3 pairs of corresponding sides are congruent. They have to be the same. They have to be equal. But in side-side similarity, the corresponding sides are not going to be equal because they're not the same size. So in this one, we have to show that the 3 pairs of corresponding sides are in the same proportion. They have to be proportional. So what we're going to do is write 3 ratios, and we need to be able to prove that these 3 ratios are equal. So we're going to prove ratios equal. Okay, you'll notice if you look at example 1 in this type of problem, we don't know anything about the angles at all. Okay, so this is purely based on sides alone. One of the key to writing these ratios is making sure that you're pairing up the correct sides. So I always look at it in terms of biggest to smallest or smallest to biggest. Okay, for example, on triangle ABC, the smallest side is 14. Well, I'm going to pair that up with the smallest side on triangle DEF. So I'm going to pair that up with 10. And I'm going to write a ratio, 14 over 10. Okay, then I'm going to find the biggest side. Well, the biggest side on the first triangle is 28. I'm going to pair that up with the biggest side on this triangle, which is 20. And I'm going to write a ratio in the same order, 28 over 20. And then I'm going to pair up the third pair, okay? Obviously, the 21 side is going to pair up with the 15 side, and I'm going to write a ratio 21 over 15. Now, we can't assume that these ratios are equal. We have to prove it. And again, you can prove it by doing a couple of things. One option is just reduce all the fractions. Okay, if I reduce this, dividing by 2, I get 7 over 5. This one, if I divide by 4, I get, 7 over 5. This one, if I divide by 3, I get 7 over 5. As soon as I've been able to show that they're all the same, that's proof that these two are similar by side, side, side. Okay, again, you've got to be able to prove that they're equal, so you have to show that. Another way to prove that they're equal is just to do the division. 14 divided by 10, and again, you can just grab a calculator if you need to. 14 divided by 10 is just 1.4. 28 divided by 20 is 1.4. 21 divided by 15 is 1.4. So again, once you have some way of showing that they're equal, now you have your evidence. And then I can come over here and say that triangle ABC is similar to triangle. Now remember, you have to match up the corresponding parts, okay? So angle A was between the blue and the green line, so that's going to pair up with angle E. So I'm going to start with angle E. Angle B was between the red and the green, so that's going to pair up with F, so EF. And then obviously that must mean that angle C pairs up with angle D. Okay, so again, really watch that you're writing the correct similarity statement, just like we did with congruence. Okay, second quick example of this one. Again, looking at this one, we have no information about the angles. So the only thing we can possibly use is side, 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 but we have to prove it. So just like with the last example, I'm going to find my smallest sides, and I'm going to write a ratio pairing up those. I'm going to write 8 over 6. Then I'm going to find my biggest sides. So that would be 16 and 12. And I'm going to write a ratio, 16 over 12. And then, of course, my middle sides, the 12 and the 9, I'm going to write a ratio comparing the 12 and the 9. Now I need to show that these ratios are equal, okay? So again, you can either reduce the fractions or you can turn them into decimals, okay? Totally up to you. I think I'm just going to reduce the fractions. So if I divide by 2, this becomes 4/3. Over here, if I divide by 4, this becomes 4/3. And over here, if I divide by 3, this becomes 4/3. So once again, as long as all 3 pairs of sides are in the same ratio, I can prove that these are similar by side, side, side. And then I can write my similarity statement. So I can say triangle ABC is similar to triangle. Now again, pair them up. Okay, angle A was between the blue and the red, so that's going to pair up with D, so we'll start with D. Angle B was between the red and the green, so that's going to pair up with F, so DF, and that means we are ending with E this time, okay? Color coding is a great way to be able to pair those up correctly when you're trying to write that similarity statement, so feel free to color code, okay? So just as a quick recap here, the 3 similarity criteria that we can use to prove that triangles are similar are angle, angle, side, angle, side, and side, side, side. Now remember, on the ones that involve sides, you have to be able to prove that sides are in the same ratio. Okay, so it's not good enough just to say, oh, these 2 sides go together. You have to prove that the ratios are the same. Okay, so a couple of quick examples, and we might skip around. We might do it just like 1 or 2 of these and then maybe have you try a couple of them. So a couple of quick examples here. Number 7, for example, we've got a couple of different angles here. We have a 38-degree angle here, and you can see that there's a sides on each side of it. Okay, so this kind of tells me I'm probably looking at the side angle side. Okay, I don't know it for a fact, but I'm probably looking at that. Over here, I have the same 38-degree angle, so that's good. That's the angle part. And then I have these 2 sides. Okay, I need to be able to show that these sides are in the same ratio. Okay, now remember my strategy though. Okay, these triangles aren't necessarily lying. When we said that there was a transformation, these triangles could have been reflected and rotated. They could have been translated. You know, any of that could have happened as well as the dilation. Okay, so when you're pairing up the sides to check, make sure that you're pairing them up according to size. For example, 10 is the smaller one. We're going to pair that up with 5 because that's the smaller one. And I'm going to write a ratio 10 over 5. Okay, then we can look at the 18, that's the bigger one, and we're going to pair that up with 9, that's the bigger one of those 2, and we're going to write a ratio 18 over 9. If we can prove that these 2 ratios are the same, then we can prove that these are similar. Again, on this one, I'm just going to divide. 10 divided by 5 is 2. 18 divided by 9 is 2. We can prove that these are equal. And therefore, we can prove that the triangles are similar because of side, angle, side. Okay? I'm going to skip B. Maybe look at C real quick here. Okay, so in C, it looks like we do have a pair. We have one set of angles, so that would be A. Okay, so right away, I'm probably looking at either AA or side angle side, right? So something that has that A in it. I can see right away that I have a 21, a side of 21, and then over here I have a side of 14. So I could write a ratio comparing those two, 21 over 14. And then I do have this other pair of sides that are marked as being equal. Okay, these 2 sides are equal to each other. That's what this little mark means, remember, from last semester. Now, here's the problem. If those 2 sides are equal, then regardless of what the number is, I could even just make up a number. Let's just call this 30, and that means that this is also 30. Okay, if I write a ratio of those sides, my ratio is 30 over 30. Well, guess what? These 2 ratios are not equal. So right away, I can tell these are not similar because side angle side doesn't work. I also don't have enough information to use angle angle because I don't know any of the other angles. Okay, so right away, I'm going to have to say that these are not similar. Okay, last example that I kind of wanted to do with you here. This one is a little bit trickier because our triangles are overlapping. Okay, we did this when we were doing dilations. Remember that when the center of dilation is on the actual triangle, then that point stays the same when the triangle shrinks or enlarges or reduces in size. Okay, this one is a little bit trickier, so I want you to really pay attention to what I'm going to do here. I'm going to redraw the two separate triangles. Okay, so for example, I'm going to take triangle A, B, and I believe that this is a C over here, triangle ABC, and I'm going to redraw that triangle right over here, label it. Okay, here's my A, here's my B, and here's my C. And now let's label the sides. AC is 36. Okay, AB. Now, AB class is the combination of 7 plus 21. So AB is actually 28. Okay, if I'm looking at BC down at the bottom, BC is the combination of these two. So BC is 32. So looking at the big red triangle, those are my three sides. Okay, now looking at the smaller triangle, okay, that would be this one right here. This triangle, again, I'm just going to draw it over here. We have point D at the top, point D. We have point E over here on the left, and then we have point B. Okay, well, the sides of this triangle. It looks like we have DB is 21, and EB is 24, but we don't know what ED is. So the first thing I know right away, class, I can't use side, side, side because I don't have all three sides for both triangles. Okay, so that one's out. I do, however, have one pair of angles that are congruent. Because angle B is the same angle in both triangles, angle B has to be congruent to itself. I don't know what the measure is, but I do know it has to be equal to itself. So right away, I have one angle. Okay, the problem is I don't have any other angles. So angle angle is also out. My only option at this point is, can I prove side angle side? So in order to prove side angle side, I'm going to look at the sides on either side of that angle. Okay, so for example, here we've got this 32, and we're going to compare that to the 24, and I'm going to write a ratio, 32 over 24. And then I'm going to look at the other pair of sides, 28 and 21, and I'm going to write a ratio, 28 over 21. And now I have to prove that these ratios are the same. So again, you can reduce the fraction. If you're not good at reducing, you can turn them into decimals. Okay, 32 divided by 24 is 1.3 repeating, and 28 divided by 21 is 1.3 repeating. So as soon as you see that these two are equal, these two ratios are equal, now I know that the triangles are similar because of side angle side. Okay, so it's a little bit of a process. You have to kind of go through the options. You have to show that ratios are equal if you're using side angle side or side, side, side. Your homework, and obviously we do have a few more problems here. Maybe I'll look at like one or two of these. I'm not going to look at all of these, but maybe we look at a couple of them. Okay, like let's say, for example, E. Okay, on E, I definitely don't know all three pairs of sides. So side, 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 that's definitely out. Okay, I do have two pairs of sides, so I'm thinking I might be able to use side angle side, but I have to have a pair of angles that are congruent. Well, I'm in luck. Remember, vertical angles are always congruent. So because I have these vertical angles, I do know that those two angles are equal to each other. So automatically I have one pair of angles, but that's the only angle I know. Okay, so angle angle is going to be out because I don't know any of the other angles. Okay, again, my only option here is side, angle, side. And I already have the pair of angles that are equal. All I need to do now is prove that the sides are in the same ratios. So just like the same thing we did before, remember, match the sides up according to their lengths. So for example, I'm going to take this out of these two sides, I'm going to take the smaller one, which is 22. And then out of these two sides, 8 is the smaller one. So I'm going to write a ratio comparing 22 and 8. Okay? Then I'm going to write a second ratio comparing the other two. But you do want to go in the same order. So since I used the bigger side on top, okay, 22 over 8, I want to use the bigger side, 38.5 over 14. And again, I have to show that these are equal. So on this one, I'm gonna get decimals. On this one, I'm gonna do the division and I'm gonna get decimals. If I do 22 divided by 8, I get 2.75. If I do 38.5 divided by 14, I get 2.75. So as long as these are equal, I can prove that these are similar by side, angle, side. Okay, and again, there's lots of different options here. I'm kind of skipping around a little bit. Here's one that you got to be tricky on, letter H. Okay, letter H. I have a pair of angles that are equal. Okay, so that's looking good so far. I have one pair of angles. I do not have all three sides, so right away, side, side, side is out. And I don't know any other angles. So angle, angle is also not an option here. Okay, the only option I have is side, angle, side. Here's the problem though, okay? If you look at triangle ABC, here's my angle, right, 45 degrees, and I have a side on each side of it, right? So I have the angle is in between the two sides. But if you look at triangle EFD, here's my angle, 45 degrees. I have this side 12, but I do not have the side on the other side of 45 degrees. I have a totally different side, a random one. Okay, this cannot be used for side, angle, side. Even if I can show that the ratios are equal, I still can't use side, angle, side because the sides aren't in the right position. So this would be an example where I would just have to say that they are not similar. Okay, so you're going to see a bunch of different examples like this. Okay, your assignment, if you check on the calendar, is a Delta Math, where you're going to have to be able to show which triangles are similar. If they are similar, tell which reason you're using to prove it. If they're not similar, just say not similar. And it may ask you to write a similarity statement like we've done. Some of them do, some of them do not. Okay, if you have any questions, please don't hesitate to email me, and if we need to, we can set up some time to be able to meet to go over it a little bit more. Good luck.